Hey the Math Geniuses, we're working on 1 today. We're talking about how we relate integers and their opposites. So that's that's the name of our topic we're getting into. At the end of this, we're gonna look at I can relate integers, their opposites, and their absolute values. We're gonna look at what all of those are. Integers are any number that we are able to count with. So you can think of any counting number that is a whole number. And it's not a fraction either. So if you're thinking of like 1/2 or 1/3 or 1/8 or anything like that, those are not integers. The opposite of any of these numbers, it's a number that when we combine in an integer and its opposite is 0. So if I have 6 and the opposite of that is -6. So for this case, when I combine those, if I have +$6 and I have a -$6, I have $0. If I am 10 feet above the water and I go down -10 feet, or I move -10 feet, I'm going -10, I'm at 0. So an opposite is the number that yields 0 when added to the additive inverse. I gotta erase as I move along. If only I had a smartboard, it would be nice. And then the last one, it's not on there, but the absolute value, that's the distance to 0. We use that so the absolute value, we denote that by putting straight brackets around something. So the absolute value of any number is the distance to 0. So if I'm thinking about the absolute value of -6, if I'm at a number line and I have a 0 and I have -6 that I went to, the distance there is 6. So the absolute value of -6, that equals 6. Throw that down on that paper too. So the key concept, an integer and its opposite, they combine to make 0. So I just showed you the one. If I have a number line and I have 0, -3, if I moved -3 from if I started at 0 and I moved down to -3, I'm there. If I move again back up, the opposite of -3 is 3. So if I'm at -3 and I move 3, the opposite, I get where I started, 0. So that's our key concept there. The main thing that we're looking at today is that if I have an integer, I combine it with its opposite, I get 0. We look at this if we're ever looking at, or if you've ever seen a rocket launch. So if we have rockets, they always will say T minus this till liftoff. You got 20, 19, 18. They're throwing in a variable there, T, and they're thinking T minus before they get to that liftoff. So after that rocket is launched, we have the 0 would be a liftoff or takeoff, and then we've got T plus referring to how long it's been in flight. They use that for any rocket that is in flight. They're thinking, how long has it been in flight? So when does the rocket launch? We have launch at 0. So they're counting down T minus 19, 18, 17, 16, and you get all the way down to 0. That is our launch point. That is when they're expecting to launch the rocket. So T, what does T represent? We could say T equals takeoff. And so if we're going to think about what integers represent this, T minus, say they're saying T minus 3, that number that is referring to, the integer, is -3. If they were saying t minus 90, they would probably say 1 minute 30, but t minus 90, they're referring to the integer negative 90. They're 90 seconds away from 0 on a number line. That integer is negative 90. Now when we look at the other one, we said t plus. If we see t plus, my marker is dying. Say I'm at t plus 3, that equals a positive 3. So if we're looking at those there, just this is an example of doing some integers. So my integers are negative 3, 90, positive 3. That's referring to how long liftoff has occurred for. Or how long until liftoff, or how long ago takeoff took off, occurred. Oh, I need to get a wet wipe for this. And you know what? I just ruined my writing ability for the rest of this video. This is going to be wet now, so I should have waited. Man. So that's one example, or let's look at an example. I'll just write it on my screen here then. So Alexis was shopping on the ground floor of the mall. She's up on the 6th floor doing her shopping, and she goes, oh shucks, I left my phone in the car. So she has to go down 6 flights of stairs to get all the way down to where her phone is in her car. And in order to get there, she has to go back down those 6 stories. So this is how it asks us, use integers on a number line to represent the situation. So what does it look like? So we can make a number line. It's kind of dry. I can write on it. So if I'm on a number line, she starts at 0, which is what we can use to represent our ground floor. Now what she's going to move away from is she's going to go down. So going downwards is going to represent negative numbers. So she could go negative 1, 2, 3, 4, 5, 6. So we have negative 6 here. So she starts at 0. She's going to move down 6 floors to get to the parking garage to get her phone. So down 6. And she goes down there, she gets her phone, she does what she needs to, she's done at her car. She's gonna go back up to where she was shopping at, and she's gonna go up 6 floors. So she'll move up those 6 floors. So overall, there's 2 integers there. One was down 6, but what's the integer to represent that? It would be negative 6. I'll put that up top, if I can. Here we go. Let me see if I can do a different marker. Blue works well for the 8th grade, so we got negative 6 was our integer for that one. So she went down from 0, she went all the way down to negative 6, that's 6 below. That's her integer that she's at. Then she goes back up, she goes up 6, so what is our integer to represent 6 floors up? That is a positive 6, or just a plain old 6. You don't have to use the plus or minus there. So what we're looking at here too though is, I told you that the absolute value for both of these. She walked down 6, the integer that we used to represent that was a negative 6, but the absolute value of negative 6 is 6. She walked down 6 floors, she walked up 6 floors. That's the distance that she walked. You can't have a negative distance. If I said, how far is it to get from here to your house? You might say 6 miles, or 10 miles, or 20 minutes. You can't have negative distance. Oh, negative 5 miles to get to my house. No, it doesn't work that way. That's not how distance works. So down 6, we're using the absolute value there to represent that one. So that's where that absolute value comes in. Let me erase this. Let's move on to example number 2. Yeah, I know. It's going to stay there. So example number 2, Sam has $20 in his savings account. So he starts with 20. He's going to get a deposit. He's going to get some cash. He's going to make a deposit of $160. So he's going to start at 20, and he's going to make that deposit and move all the way up to 180. So we had 20 plus 160 equals 180. So right now in his bank account, he has $180 sitting there. But then 2 weeks later, he's going to make a withdrawal of $160. So he's going to take that 180 that he had. He's going to subtract $160, and he's going to withdraw. That's the word for that for a bank account, if you don't know. And so he's going to end up back at something there again. It's negative, positive $20. So what integer represents Sam's deposit? What integer represents that? So he's got his deposit. He's going to be 160. Poor handwriting, sorry. So his integer for his deposit is $160. And then what integer represents his withdrawal? Well, he took out 160, so that is what it is. Negative $160. And those two numbers are opposite. 160, negative 160. They're opposites. When I combine those opposites, I have a 0. So over this 2-week period, there's a term called net change. His net change for his account was 0. He started with 20. Yeah, he went up to something else, but at the end of that 2 weeks, he came back down to 0, or back down to 20. So his change was 0. That's where this plus 160 minus 160 is going to affect that, and he has a change of 0. All right, let me erase that. One last example here, and then I'm done for this. So we're looking at, excuse me, so we're looking at weather changes here. And this looks like it's possibly a typical Ohio day. One winter morning, the temperature was at negative 2 degrees below 0 Celsius. By 11 a.m., the temperature had risen an integer. We don't know that yet, or we don't know where it stopped at, but it had decreased by 3. And then by 4 p.m., it was back up to 0 degrees Celsius. So what integer represents the temperature change from 11 to 4? We're going to illustrate that here. If you want to do it on your own and then check yourself or challenge yourself, you can pause this. So let's start with our line, though. We're going to start at negative 2. And by 11 a.m., it had decreased by 3 degrees. So 1, 2, 3 degrees of decrease. And this was from 7 a.m. to 11 a.m. And then at 4 p.m., the temperature had reached 0. So we're going to go from 11 a.m. all the way up to 0. So what integer represents this number right here? This is what the question is asking. What integer represents that? And so if I look at that, I've got negative 5. How many degrees did I increase by? So if we're going to count, we got 1, 2, 3, 4, 5. So this was a positive 5 degrees Celsius, or a 5 degrees of increase, is where we can think about that. So, if you have any questions, let me know.